Welcome to the Nokia Optical Networking Learning Essentials video series from the Nokia Optical Network Certification Program, an end-to-end learning program supporting Nokia 1830 PSS, VWM, and NFM-T-based networks. Today, we'll look at the Nokia Optical Fronthaul link end-to-end configuration for 5G networks. This video has been created based on the Nokia Optical Transport for Mobile Services course that plays a key role in the Nokia 5G learning curriculum. Optical technologies and architectures based on the 1830 Versatile WDM Module, or VWM, are proposed for Fronthaul to meet 5G requirements along with the time-sensitive packet switch, or TPS. The 1830 VWM solution is an effective way to establish Fronthaul links connecting the central office with the radio sites. In this video, we'll explain the main components of the VWM solution and the main configuration parameters to ensure the end-to-end transmission is working properly after the physical connectivity has been set up, including the CPRI rate, DWDM frequency, and software loopback. Several technologies can be used to enable Fronthaul connectivity and connect the baseband unit, or BBU, with the radio site. One of those is based on the VWM solution, which can support active, semi-passive, or passive architectures. Several components belong to the VWM solution. Some of them are passive. Others can be used in a passive or in an active mode. Some others, instead, are active and related to active architectures only. We will now focus on this configuration, which is mostly based on two components, a translator and a MUX/DMUX. The former is named Translation Line Unit, or TLU, and it is used to convert black and white to colored signals and vice versa, or CWDM to DWDM signals and vice versa. The latter can be a Photonic Managed Unit, or PMU, for CWDM applications, or a filter such as the SFD44 or the SFD96, for instance, for DWDM applications. In one direction, this is used to group multiple signals onto a single line span. On the opposite direction, an aggregated signal flow is split from the line span onto multiple fibers, depending on their frequency. Among the components available in the 1830 VWM solution, the TLU is where we do most of the configuration steps. Other components, such as the PMU for instance, once fibered correctly, no further configuration is required. So let's have a closer look at the TLU. This is the TLU block diagram. 9 traffic ports are available on the left, and the other 9 traffic ports are available on the right. Here is where the translation, the conversion, takes place. In a typical scenario, we will have 9 black and white signal flows entering this device and other 9 colored, either CWDM or DWDM signal flows leaving it, and vice versa, as it is bidirectional. Other important ports are those related to traffic monitoring. The target of the following exercise is to bring the end-to-end connectivity up for the first channel. Here, in this network diagram, the VWM devices are highlighted along with the related connections. We will connect to the OSU, or Optical Supervisory Unit, and we will configure the TLU devices properly. To do that, some parameters need to be properly configured, and specifically CPRI rate, DWDM frequency, and any loopback should be removed. Let's start by checking the testing set. We do have some traffic issues as the traffic is not passing through as expected. As requested by the exercise, let's check the CPRI rates of TLU number 2, number 1, ports C1 and L1 with the following command. Show CDR channels brief. As we can see, the CPRI rate for the couple C1 and L1 is equal to 1. Rate 1 is wrong, and therefore, let's set it to 3 after shutting down the related ports. Config interface TLU 2, 1, L1, status down. Config interface TLU 2, 1, C1, status down. Config CDR channel TLU 2, 1, 1, rate, CPRI rate 3. Config interface TLU 2, 1, L1, status up. Config interface TLU 2, 1, C1, status up. Let's check whether the CPRI rate is now 3. Show CDR channels brief. Yes, the CPRI rate for the couple L1 and C1 is equal to 3. Now, we need to check the DWDM frequency on the same device, and on port L1, which is the one configured in DWDM colored mode, while C1 is black and white as it is connected to the BBU. Show interface TLU2-1L1 transmission frequency number. The frequency is not the same as it should be according to the exercise, and therefore, let's change it with this command. Config interface TLU2-1L1 transmission frequency number 9410. Let's check if the frequency is the expected one. Let's now check whether any software loopback has been set against TLU number 12, number 1, port L1. Show interface TLU12-1L1 loopback terminal. Show interface TLU12-1L1 loopback facility. This way, we can check whether we have either terminal or facility loopbacks enabled. Here, it looks like we have a terminal loopback enabled. With the following command, we can disable it and recover the full functionality of port L1. Config interface TLU12-1L1 loopback terminal disabled. Config interface TLU12-1L1 status up. Let us once again open the testing set to check whether the traffic is okay. The historical data should be cleared, and it is now green, which means our traffic is up. In summary, in a VWM-based fronthaul link, several components are present, but one of them is used for most of the channel configuration parameters to be issued, the TLU. Through this active component, the user can define the CPRI rate per channel, configure the DWDM frequency where DWDM channels are used. In case CWDM channels only are used, typically their frequency is predefined with the pluggable and cannot be changed via software. Establish software loopback on both client and line ports. The loopback type can be either terminal or facility, meaning that each channel can be tested in 4 possible ways. To make sure that the end-to-end flow has been set up correctly, it's necessary to configure these parameters consistently. And remove any software loopback to allow BBU to, from RRH communication. Thanks for watching, and look for more videos in our Optical Networking Learning Essentials series. Whether your goal is to enhance your optical networking skills or demonstrate your expertise through one of our 4 industry-recognized certifications, the Optical Network Certification Program is here to get you, your career, and your organization on the right path. Our program features 9 instructor-led courses developed by our team of subject matter experts using industry best practices, use case-driven examples, and hands-on labs. Learn more and get started today by visiting our website. Thank you.